Hey folks, we're on 7.8 trig ratios, trigonometric ratios. We're going to be talking about them. It may be a little bit confusing, but it is okay. We will work with them until they are not confusing. The biggest and most important thing about this unit is knowing where and how to identify adjacent sides, knowing what adjacent means. Um, we're knowing how to find the hypotenuse in a triangle and knowing what we mean when we say the opposite side, okay? But the objective of this unit, or rather, excuse me, this lesson is for you to be able to define trigonometric ratios for acute angles and apply those ratios to solve for sides of right triangles. So in the diagram below, there are two right triangles, each with an acute angle of 35 as marked. The triangles are similar because of angle-angle similarity. They have a set of congruent corresponding angles. Okay, so these are similar triangles. One is smaller, one is larger, but because they have a set of congruent corresponding sides, they are similar. Now, the trig ratios come out of right triangle similarity. Okay, that's where they come from. And that's why they're used in order to find missing sides and angles in right triangles. In order to keep this lesson shorter than my usual lessons, I'm skipping this section. You are welcome to do this section on your own. I've also changed some of the questions or prompts and made up my own questions and prompts, okay? So it says here, what are the trig functions? What are they? Well, they're sine, cosine, and tangent, or sine, or sin, cos, tan. That's how they look on the calculator. And they are functions that represent the ratio of sides of a right triangle. Now, you're going to deal with these ratios, and I'm going to just show you what they are now. Okay? So we have sine, cosine, and tangent. Again, they help you to find missing sides, and that's what I'm going to be explaining. The sine of any angle is found by taking, in that triangle, the opposite side and dividing it by the hypotenuse. The cosine of any angle in a right triangle is found by taking the adjacent side and dividing it by the hypotenuse. The tangent of any angle is found by taking the opposite side in that right triangle and dividing it by the adjacent side. Okay? We're going to talk about what these words mean. We know what a hypotenuse is, but we're going to talk about what opposite and adjacent means. So we talked about the what they are. Let's talk about the why. You do need to have all of this written down when I check it on Monday. Let's talk about the why. So why do we use them? We use the trig functions or the ratios that they create to solve for missing sides when we cannot use Pythagorean theorem. So sometimes we can use Pythagorean theorem given we have enough information, but if we don't, we can't use it. Like in this case, we don't have enough information here to use Pythagorean theorem. We only have one side, and this is not a 30, 60, 90 right triangle, nor is it a 45, 45, 90. So there is not enough information. The trig ratios will help us figure it out, okay? I'm turning the page. You can also use the trig ratios to find missing angle measures, and we'll get into that probably by Wednesday. Okay, so define the three fundamental trig ratios. So we did talk about that, but I do want to talk about what it means for something to be adjacent and opposite as it pertains to the trig ratios. So in a right triangle, a trigonometric function of an acute angle, that means any other angle except for the 90-degree angle in a right triangle. So any other angle except for this one. That's what they're referring to when they say a trigonometric function of an acute angle. That means either A or B. Compares two side lengths, outputting a ratio. And we have to talk about how we get that and how it's labeled and all of that. So this theta here is a Greek letter. It's just used as a variable in math to represent an angle measure, okay? So we talked about sine, cosine, and tangent, all right? So sine of theta, what do we mean by sine of theta? So the sine of the angle where theta is going to be equal to the opposite over the hypotenuse. What does that mean? The sine of theta is going to be equal to whatever segment is opposite theta, which is CB in this case, divided by the hypotenuse of that right triangle, and that hypotenuse is AB. The cosine of theta, this is theta right here, is going to be equal to the side adjacent over the hypotenuse. Adjacent means a segment that is on the same side of the angle that we're given, and in this case, the given angle is theta. So the adjacent side would be AC. Okay, so a side can either be adjacent or or opposite, or it can be the hypotenuse. In this case, to find the cosine of this angle of theta, you would take the adjacent side, which is AC, and divide it by the hypotenuse, which is AB. To find the tangent of theta, you would take the opposite side, the segment opposite, which is CB, over the adjacent side, which is AC. Now, what's key here is to know that the adjacent side changes based on the given angle. The segment that is, so the definition of adjacent is the segment that is on the same side as the given angle. But what I wrote here is that it changes based on where the given angle is located. So say I wanted to find the let's do the cosine of angle B. If I wanted to find the cosine of angle B, theta would actually be here, and I would take the adjacent side, BC, right? The side adjacent to theta, if it was here, is BC over the hypotenuse, okay? So the adjacent side changes based on where the angle is, or where the angle that you're referring to is located. The hypotenuse is fixed. So the hypotenuse is always the segment directly opposite the right angle. So the hypotenuse is never going to change. It's always in the same place. It's always located directly opposite this 90-degree angle. The opposite side, though, does change. The opposite side is like the adjacent side. It changes based on the given angle, and it is the segment that is opposite the given angle. Okay? For example, if theta was here instead of here, so I'm going to change my theta, right? If theta was here instead of here, then when we talk about opposite side, AC would be my opposite side, because, and say we're trying to find the sine of B. AC is opposite, so it would be AC over AB, because theta is here now, and so now this is my opposite, as opposed to when theta was here, CB was my opposite side. Let's test that out. So we have to try it out with this triangle here, and it says to determine the following trig ratios, leave in rationalized fraction form. So first one asks us to find the sine of angle A. So angle A is here, okay? Angle A is right there, and so I know the sine is equal to the opposite over the hypotenuse. The side opposite angle A is 1. The hypotenuse, which is the side opposite the 90-degree angle, is 2. Therefore, the sine of angle A is 1 over 2. Let's try the tangent of angle A. The tangent of angle A would be the opposite, or the tangent of any angle is the opposite over the adjacent. Angle A is here. Side opposite A is 1. Side adjacent to angle A, well, angle A is here, and this is the hypotenuse, so the other side has to be the adjacent side. because it is on the same side as my angle, okay? So that's 1 over radical 3. It says leave in rationalized fraction form. I have to multiply radical 3 by radical 3. I'm going to end up getting radical 3 over 3. I can leave it in that form. And I know my video is extending longer than I wanted it to, but let's try cosine of angle C. So I want to find the cosine of angle C, and to find the cosine, I take the adjacent over the hypotenuse. My adjacent side, so now this is angle C. The side that is adjacent it's not going to be this side right here. Even though this is adjacent to C, it is the hypotenuse. The hypotenuse cannot also be the adjacent side, okay? So if it's not this side, it is this side, all right? And that's 1 over the hypotenuse, which is 2. Okay? What I noticed is that the sine of angle A is the same as the cosine of angle C. That's interesting, and we're going to talk about that later on. Okay, so this video is stretching out a little longer. You are going to be responsible for doing the rest of the try it out questions, and just try your best on them, okay? If you have any questions, shoot them in the description box or shoot me a Jupiter message. Okay, bye.